Hi, Dr. Cap. Travis White-Velez here with this week's Advanced Concept Interactive presentation. For this week's presentation, I'm just going to set it up briefly, and then I will explain a little bit more about it in roughly 6 to 10 hours. So for this experiment, I'm using gummy bears. I have distilled water, and then I also have just good old-fashioned plain table salt. And the table salt will go in with regular tap water. So I will fill that now. So in the regular tap water, I'm going to just pour a bunch of salt. All right. And then I'm also going to grab a handful of gummy bears. Or I'm just gonna pour a bunch of gummy bears in there. I'm going to give that a good mix with a spoon. So that solution is preparing. I am now going to grab another container. I'm going to put gummy bears in this container. One second. Gummy bears in that container. All right. And then I'm going to pour the distilled water into that container. And then I'm going to let those sit. I'm going to cover them both with a lid, and I will see you back in roughly 6 to 10 hours with an explanation why what happens, or what happened, why it happened rather, and I will have some more definitions and things like that for you all. So thank you and stay tuned. Hi, Professor and class, or whoever's watching. I am back. It has been roughly 7.5, almost 8 hours at this point. So a little bit about it. My quick prediction is if a gummy bear is placed in water, it will swell. And if another gummy bear is then placed into salt water, or a water that is higher in salt concentration, then the gummy bear will decrease in its volume and mass. So for this experiment, you need gummy bears, you obviously need the containers, distilled water, you need regular just tap water and salt, and obviously a spoon, or you can use your hands to mix. So in this, essentially, you're looking at two types of solutions. You're looking at a hypertonic solution, and you're looking at a hypotonic solution. In a hypertonic solution, the cells, or in this case, a gummy bear, it shrinks. And that has to do with the water molecules inside of the gummy bear essentially want to go from a concentration of high to low. Because there is more salt inside of the water in the hypertonic solution, you have the water molecules wanting to go outside into the water to equalize the difference between both the salt concentration and the water concentration. In the distilled water, it's actually the exact opposite, so to speak. You have a hypotonic solution where the concentration of salt inside of the gummy bears is greater than that of the distilled water or the solution surrounding it. So the water molecules in this case then try to go inside of the gummy bear to equalize the difference between the gummy bear and its surrounding area. So here was the gummy bear that was placed in salt. I don't know if you can tell, but it did, you know, shrivel up a little bit. And here's what they look like in there. And then this is the gummy bears placed in the hypotonic solution. I don't know if you can tell, but they have actually changed in size considerably. It's got to be delicate when picking them up. But, oh, that one broke. But here is a gummy bear that has been placed inside of a hypotonic solution. And here is one placed inside of a hypertonic solution. You can see a definite size difference from when we started, roughly 6.5, 7 hours ago. And with that being said, I will be back in just a moment to explain a little bit more. I'm just going to clean up and I will see you briefly. All right, so now that I've cleaned that up, I will actually explain a little bit more behind this. So this is a lab essentially on osmosis. So you have, I'll use a cell membrane in this case. So a cell is surrounded by a semi-permeable layer. That layer is composed of a lipid bilayer. And semi-permeable just means that there are certain things that can get through, certain things that can't. In the case of most cell membranes, you have a layer that is permeable to smaller molecules, and then larger molecules cannot get in. So osmosis is essentially the process of diffusion, something moving inside of a cell or something moving outside of a cell, which in this case, again, I'm using a cell membrane as the example, just because it helps me understand it best. So essentially the way that osmosis works is you have an equal number of water molecules inside of a membrane, and that's isotonic, equal iso. When sugar molecules are added to one side, for example, it becomes hypertonic because there are more sugar molecules in one side versus the other. Water moves across the membrane from the less concentrated, the hypotonic side, to the more concentrated, the hypertonic side, until the concentration is equal on both sides, and that's called equilibrium. In the sense of, in the example of the gummy bears, you will have, it's going to get to a point where the gummy bears can only shrink but so much, and they can only grow or swell but so much. So in this case, the gelatin in the gummy bear is similar to a cell membrane. Gummy bears are placed in water. Water moves into the gelatin because there's more sugar molecules in the gummy bear than there are in the water. So the gummy bear grows. The exact opposite happens in the shrinking gummy bear. Water moves outside of the gelatin because there's more salt molecules in the water than in the gummy bear. And I just want you to remember, for the point of this experiment, water is just going to be, it's the solution. The gummy bear grows and shrinks. And like I said, it gets to a point where the gummy bear is either going to not grow anymore or increase in size, and it's not going to shrink anymore. And in the case of growing, it actually may burst or lyse. But essentially that was a quick way for me to understand this. I had to put it in the form of a cell membrane just to kind of understand osmosis and the movement of, water molecules and salt molecules and hypertonic, hypotonic, and isotonic solutions. I hope this helps someone understand a little bit better, and I hope everyone has a safe week and a great semester ahead. Thank you and take care.